So, good morning, all. My review topic is about advanced semantic partitioning and automated model validation framework. So, this is the system flow diagram. First of all, this data set processing, and then the process has to be partitioning using the semantic partitioning. So, then the threshold for basic segmentation. Then comes the region based segmentation, then edge reduction. Then we have to do with model validation, segmentation, refining, evaluation or testing, fine tuning. Then the last step is hyperparameter optimization. First of all, threshold for basic segmentation. There are two types of thresholding. So the first thresholding is global thresholding, so which is the type of thresholding that is applied to distinguish the defects from the background. Thinking of like you're drawing a line pixels that is brighter than a flag as potential defects, while the other is treated as the normal background. Like, it is a straightforward technique that can able to work well when the fabric is in even lightning, and the camera can be easily to capture the image, and it can be able to recognize whatever the defects have been there in the fabric. And then global thresholding is ideal for some images with consistent lighting and minimal noise. This is the output that we have got. Like, you can able to see in the defect areas the black is being given highlighted, so that we can able to mark it up like this is the defected area. Then comes adaptive thresholding. Like, this type of thresholding is basically implemented in the uneven lightning, like which comes with some complex pattern. This is the better choice for the basic global method. So instead of using a single threshold value for the whole image, like this techniques can be used so that it can able to locate the small local region and can able to calculate the threshold for each pixels based on the brightness of its surroundings pixel. In the adaptive thresholding, even we have again two types of thresholding, like mean and Gaussian. So mean is like we just calculate the average intensity of its surrounding pixel within a defect block or window. Like, the constant values is subtracted from the pixel value, and then you will got the mean value. Accordingly, you will calculate the adaptive mean thresholding. And in the Gaussian page, you will be getting the weighted average, where the pixels that are available closer to the center of the blocks are given more influence using a Gaussian function, like a gradual lightning variation such as arrows and glare. This is the output that I've got for mean and Gaussian thresholding. So the next is region based segmentation. In this we have region based region growth. Region growth is like just in the real life, just take an example of fiber, not a fiber, fungus. You can able to see the first starting position of it, and then you can able to see the nearby neighboring places the fungus start to grow. The same wise, here we have a seed point, which is like a single pixel that is likely to be a part of defect. Like, the seed can be selected using tools like edge reduction, or it can be used or selected by other methods. So the parameters that we use for region growth is like intensity threshold, which can able to define how similar pixel brightness must be even when it is compared to seed point. So connectivity is like it just determines whichever surrounding pixels are considered neighboring. And this is the images, this is the output that we have got for region growth result. And the next is watershed algorithm. You can able to see it can able to produce the output that looks similar to topographic map, where the intensity levels are treated as elevation values, like valleys and ground. So the algorithm, which can looks similar to the intensity gradients area, where the pixel value change sharply, and the gradients also change to the segmentation of the image. So this is the output. On the edge detection method, we have two types of detection. The first is canny detection. So it works for a series of steps that can be able to highlight areas where there is a sharp contrast in intensities, so which often marks the boundaries of object or reflect. So this type of process that can be able to involve high gradients areas in the images. So this is the example of canny edges. Contour detection. So it comes under segmentation, refining where we'll be drawing the outlines around the segmented areas, that is the defected areas. Like it can help you to see the exact borders of each defect. Like this make it easier to understand why the damage occur and where the damage occur. And the evaluation and testing. So in whatever model that we have trained, we have to go through the testing part to fine tune with the validation set. So the test set serves as a completely unseen data set to measure the model's generalization ability. So this model evaluation step, it just ensures whether it can able to train the data good, and it is genuinely learning to make accurate prediction across diverse fabric images. So you can just see this is the training image, and in this you can able to see just the whole is predicted, and the precision, recall and effort score are calculated even with the macro average and the weighted average. So accuracy is nothing but the overall correctness of the model. So it comes in the model accuracy, while the precision and the recall are particularly important for handling class imbalance. So the F1 score is used to produce a balanced measure combining both precision and recall. And this is the percentage and the predictor label for the predictor label and the truth label for the holes and the types of defect that we have been trained so far. And this is the model accuracy value, like precision, recall and effort score. And thank you, this is my a review, and I have completed the project. Thank you.